Hello, I'm Yaroslav from Lightnovo Customer Support, and today I'm going to demonstrate the capabilities of Lightnovo SDK, software development kit with which you can develop your own programs in Python and C uh, using Lightnovo devices, data acquisition from the devices, visualization of data for your own workflows. And so today I'll focus on the SDK in Python. And I have a mini Raman device. This device you can see connected to my computer. So in this specific example I'll show today, and let's go through the code. I will show the sequential acquisition of spectra, logging them to the CSV file, and then plot in time series with a separate program timescan viewer, also developed in Python. So let's go through the code. Uh, Here we input tkinter, which is a graphical module for Python. Then we import LNMR, which is Lightnovo SDK, then some modules from Python, time to access time, then NumPy, matplotlib for graphical plotting, threading for multi-threading, CSV for the export to CSV file. This, except of LNMR, other modules, they are not necessary for functioning of SDK. All SDK is included in LNMR, but it's just I show more extensive example. So let's go through the code itself. So after input section, we connect to the device. We'll time the connection. I'll show how fast it can connect. We time it using time module. Then when the spectrometer is successfully connected, it's reading the settings from the device, for example, Raman shift range. Then the device settings are set up. So I'll use, for example, over here, laser power 50 milliwatts. In the beginning, the laser would be off. And to track the laser state, I have the variable laser state. We'll try to work with exposure times 300. You can set it here. And repetition count 1. Then we'll do as well gain 1, and then we'll do sequential acquisition. Then basically some standard tkinter GUI code, the size of the window, then the plot of the spectrum. Um, then later what we have core functions, run single capture, which is over here, append scan to log of scans, update plot, and then scan loop for scanning, and so toggling scan, um, and toggle laser, which basically laser on off function, exit the app function, and there are buttons in tkinter, basically laser button to toggle the laser state on off, capture button to start or stop capturing, and exit button. There is no need to specify a file name because the file name would be a timestamp, and then everything is logged in the file depending on the time passed, and then it would be another column in the file. I'll show it to you. So let's start. So let's attach some sample to the probe. It's a standard Lightnovo polystyrene reference, and we use middle distance probe. We'll launch the program. So to launch it, it's Python timescan.py. We started. So unfortunately, in my setup, it started in another window, so I have to drag it. Then you can actually start the time scan. Even before starting the laser, you can do it the other way around, it doesn't matter. And this program start time scan, so now it just, because the laser is off and then the spectrum is zero because it's also blocked, it's not exposed to sunlight. We turn the laser on and you see a nice spectrum of polystyrene. Then I can adjust focus and distance, and as you can see, it is changing the amplitude of the signal as I rotate the. So now you see it went down because it's out of focus. So I also have, let's bring it back to the maximal signal. You can see, oops, it was before, so like here. As you can see, if I don't touch it, the signal is quite stable. I have a couple of different samples, and actually now when I remove this reference sample and I expose it to sunlight, you can clearly see solid spectrum. Then I block it with my hand. There's still some scattering, and the profile looks like that. Then I have a paracetamol tablet. Here we can see a nice spectrum of paracetamol, ibuprofen, and actually over here it looks like it has titanium dioxide coated low frequency peaks. Well, relatively low, 500. Then I also have some piece of plastic, white plastic, and we see some Raman lines. I just need to position it properly. But yeah, anyways, here they are. So now it's, anyways, yeah. Let's go back to the code itself, and then now we can actually stop the time scan, the code to the SDK. We stop the time scan, and let's see what we have. And actually, all the files are logged in the same folder. Of course, the past file can be modified. And let's open the latest one. There's time scan. And as you can see, scan index can start with 1, 1, 2, 3, 4, 5. It's first column. Time elapsed since you click the button in seconds. Raman shift and intensity. And I can scroll. So for example, over here we have scan number 26, 36.9 seconds passed, and Raman shift 836, intensity 5.6, and so on. And this is the log which we did. Right now we have just done it, and it contains 167,000 lines. Anyways, so let's go to another program, how to open it and visualize all these scans, because the program I just showed it was for data acquisition, was showing the scan live, only one spectrum. So I have a code for this time viewer, so which basically opens. It's again a TK interface and some using standard modules of Python such as NumPy, Pandas, Matplotlib. It is written in the file and is visualizing it. Basically, just about 150, 171 lines of code. And let's launch this example. Let's exit the timescan program. And we do timescan viewer. here it is. We open the time scan, the latest time scan, and it's plotting it. As you can see, here are all the spectra together, colored by elapsed time. You can show other examples and measuring other stuff. So it's another example. Again, we see over here, back then I was measuring polystyrene and that scan ibuprofen tablet as well. Thank you for your attention, and if you would like to acquire an SDK from Lightnovo, please contact us. Thank you.